Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 22. 23, sorry, 23. So in today's lesson, we're going to be talking about a stack. So last lesson, we were building up an example, and we came to a place where I was like, I want to use a stack, but we haven't talked about it, so let's talk about it today. So stack's a data structure for structuring data in the specific order. That order is called last in, first out. You might see it spelled out as LIFO. The idea with that is you put items onto the stack, and then as you get them off the stack, you get the latest one that was there, and you use it like that. Some examples of that. One we're going to do today is just going to reverse. We're going to do a reverse on a string, and we're going to do it with a stack. Other examples, when you have a programming language, you have all the different symbols, like here, each one of these, we have this, we have the braces, all of them could get pushed on the stack and then popped off in the reverse, and you can see if they what's inside of everything, and you can use it to parse things like that. Let's go through an example of a stack really quick. So, say the most common example is always at restaurants, they'll have a stack of plates, and what you do is you put plates on the stack, and then as you take them off, you'll take off from the top. So the idea of putting something on the stack, you push something on the stack. So let's say I push A, it goes into the first slot. Then we go on and push item B, and A goes down. And you keep doing that. So we'll push on a C. So there's the idea, and it keeps going down, and we're going to use a list when we implement it here in a few minutes, so it'll just automatically grow, but you could do it in an array as well and just expand it if you needed it. However you need to do it, if you have a limit, something like that. So that's pushing on the stack. You can also pop something from a stack, so the idea of popping it is you get it off the stack. So we go back to that, and the user would then have C and could mess with C if they needed to. C#, there's one more thing, because if you just pop a stack and it's empty, it's going to throw an exception, but there's a peek method as well, and peek lets you say, okay, what's on the top? Okay, and it's B, and you can use B, but you have to remember that if you peek, the item isn't actually removed at all. I should actually check to make sure that's right, but I believe it's not removed. And that's the basic operations: peek, pop, and push. You push onto a stack, pop off the stack, and peek special. Let me check really quickly. Yeah, it returns the object at the top of the stack without remove. Alright, so let's go ahead and do a little class here. Let's do save this. We'll do my stack.cs. Alright, so we're going to do it generic. In reality, all I'm going to do is use strings in the example, but we'll go ahead and do generic while we're at it. So the backing data structure is a list of T. We'll call it items. So the first method is push, and push is easy. Look how easy that is. So that just pushes something onto the list. So as the list gets bigger, like over here, so in that same example, if we're restructuring it, would be A, B, or A, then we push B, and then we push C. Then all we're going to do is remove the last item from the list as we go through it. That's all we're going to do. So that makes the operations easy. We just keep adding to the list, and when we want to get the last item off or peak, we just check what the last item is or remove the last item and return it. So not that complex. So that's all you need to do for push. So pop on the other end has a little more, but not a lot. So we'll do something like this. So turns T. So if we're going to throw an invalid operation if there's no items. So count equals 0. You could set this if you didn't want it to throw an exception. You could also go that route if you wanted. We'll throw this and say the stack is empty. If it's not empty though, then we can just get the last item. And here I don't think I've showed this. What we can do is we can do a caret and 1. So that just says the last item. I'm going to see if it says. I don't think I've ever used false or turn that to true. I bet we could do that at 2. Or not. We'll just do caret 1. I'm not actually sure what that's supposed to indicate there. The from end. I've never actually paid attention and seen that, but I might take a look at that later. But here's what I'm going to do. And the caret just says start from the end and go back. So start from the end and get the last item is what this is. This is equivalent to say we wanted to do something like at items.count -1. That would be the same thing, I believe. Here, I think we can even see if it tells us that it is. Yeah. So that's how we could get the last item. So then we need to remove it from the list, though. So then we would do items.remove at. And here's where we're going to need to do that anyway. So what we might do here, just save off the last index and do it like that as well. But return last. If we didn't want it to figure out what the last position was, but I don't think it's going to be that important. You could do something like last index equals items.count -1, and just use last index. That would probably also work. I probably like the other one better just because I would understand it, and it's a little shorter. But I'd have to think on that. I may like the other one better. Let's continue. Let's do a peak. So peak's really easy as well. So it is just going to grab the last item. We don't remove it or anything. So I say it's really easy. Let's check what happens there if there's nothing on the list. That may actually fail. If it does, we'll adjust. So a count, I always like a count. And we'll do an empty just to make it empty. It's clear, isn't it? Yeah, clear. Oh, yeah. Oh, there's the problem. It doesn't need to be returned. It's not returning anything. What I was thinking of, I mixed up what I was thinking I was going to do is empty. That return items.count equals 0. That one can, that was what I mixed up. I was going to do both of these and just out of the other one. So let's do let's test this here and see what happens. So I think this will be all we need though. So we'll test the peak method here because I actually didn't try it. So we'll see what happens. So let's do stack of string. Let's do stack.peak. Cool. Let's see what this does. That was right. Notice I've got the implicit usings on because that's what it defaults to. So that's why you're not seeing my, I guess it's in the same namespace, so it doesn't matter, but the system here name can be simplified, but there's no using system up there. Yeah. Index out of range. Let's fix that. We'll just do this. Let's make this an expression body move it from this. If let's do just this is empty. I don't think that's what I want to do. Let's see. That may work. Let's do yes, that may be closer to what I'm wanting to do. That maybe. Okay, so that is what I want. Okay. So there. Now we have this implementation. We'll just read only. Okay. So let's play around with it. So our example before was put let's do stack dot push push A push B. Let's do one more method. Let's add a print. Public string to string. Public override string to string. So let's return. Let's do comma space and items. We'll do it like that. Let's do one more thing. Let's reverse. Reverse doesn't do it. We'll just do it in the regular direction first. direction. We'll just do that. So there, now we have a print. So let's do a print. Outline stack dot string. Right. Item equals stack dot peak. Copy this. Let's instead do factor. Extract a local method. Call it we lost. Let's call it print item, maybe. And I don't pass in the stack. I want to pass in the item. Just like that. We'll call it. There we go. It's F2. I'm used to pressing RR or Control R. Let's see. Let's do item. Go ahead and run .NET Run while we're going. Let's do one more thing. Let's copy this line and show that the item's still there. Can be null, so let's fix that. Copy and do it again. So there we go. So now we'll see that that it's not null once it runs. There we go. Item is null. There's the list. Item is not null now, and we kept it. So that worked all right. We'll do. Let's show pop now. So let's just pop off the item. So peak doesn't get rid of it. Now we'll do item equals stack.pop. So now we've checked that the item's there. We would do what we would do here is if item's null, throw exception or something. However, we know this is not the case because we just checked. Now, what we could do is grab the item. Now, if we print it, we should see the same thing, same result. But now, it should be just A and B. Now, if we do one more thing, if we do, let's say we push D now. Now, if we do that, if we print the line, C should be completely gone out of the list, and we should be good. There we go. There's just a very short example. Let's go ahead and use this example now. So I'm going to pop this. So let's do console.writeLine. Enter your sentence. console.write string sentence equals console.readline. I'm thinking I might rather just do this as a string. We'll continue. Read line. So if sentence now string dot is null or white space sentence throw new sentence is invalid. We'll trim it just to clearing off any extra white space just in case. And then let's flip it. So we could do something like split on space. There we go. So now it's separated. So now what we could do is just put these onto a stack. So for each string s in split. Then we can just do stack.push s. Now we do reverse. We do do it like this: string reversed equals empty. So let's do string word equals stack.peak if word. Let's do is null or white space word yeah. Let's do this. Here for this though, we do need to do we'll do it like that. So there we'll remove any empty entries and we'll trim the entries if there's just white space. So this shouldn't happen, but shouldn't happen, but we'll do the check just to be thorough. Else reverse plus equals. There we go. Now while stack dot is empty, it's not empty, we do this. Now that's going to put an empty space at the end. I guess we want to do it one time first and then do it. We'll do it one time out here. Then we'll do it on the inside. This time we'll add the space. And that should reverse our string. So let's do console.writeLine reversed. So there we go. That should have us up a leave. So let's see what happens. And we'll see what I missed, because I think I missed something. I think there's one thing I'm missing. Let's enter a sentence. I think I messed it up, but we'll go with it. So the period is going to end up at the end, but that's it. And it looks like it didn't work because we used peak and not pop. Okay. So yeah, so we made an infinite loop. So that's what I thought I missed. So let's do this. Let's do word.pop. Word equals that pop. And technically we could just use the peak up there. That'd be fine as well. Now let's do it. I'll just copy my other sentence here, even though I don't think that's the right sentence. There's some sentence here that's almost this that has every letter of the alphabet. Two dogs. Oh, yeah, that makes sense. Yeah. Need to pop it too. Let's pop. Let's try it one more time. I'll enter my sentence once more. Oh, Glazy, the overjumped fox. That seems to be it. Yeah, okay, so there we go. Did a reverse string very quickly. So that's just sort of what you can do with it. Let's clean this up just a little. This looks very repeated. This part at least. So what we could do here is let's do refactor this. Call this, we're going to press F2 this time. And we'll call this get word from stack. Okay, copied it. There we go. This should do the exact same thing we just did. We'll check that, but I'll do it. That was a failure. Yep, okay. So there we go. Nice and easy. I'm going to clean that up just to make it a little shorter. So here's something we haven't talked about before, but let's look at something new here while we've still got a little time. So right now we're just appending to the string reversed here. It's actually really efficient. When you do strings, they are fixed size. So once you create one, they're immutable. So once you create one, you can't change it. So what C# does is each time we concatenate, we just create a new string each time and build it up. And for one this short, you can see it doesn't take long. But once you start getting bigger strings, this can actually start adding up. So there's a way around that. So let's do this. We'll do string builder reversed. Move that. Have to use a new using system.text. Do it. Yes. So here we can't just do this, but what we can do instead is append word equals new. It's an object. There we go. And we'll do that here. Probably just use join to be totally honest, but we're not returning it, so we'll actually use the stack we've just created. There we go. Now, the last step here is the toString, which this does implicitly, but to get an actual string out of a string builder, you would do that. You can see here, interpolation can be simplified just by the virtue of being inside of these braces of toString it. But here, we'll do the same thing, and this one's technically more efficient, although for a short string like I'm about to put in it, it's debatable. String builder can be nice, especially if you have longer ones or large ones. I think most things in it are fairly straightforward. Append and format. I'm append join. I think this will. I'd have to check to see, but I think this takes a separator and a value. So just like a string join. Format just takes the format string. Not that complex. Then line acts like console.writeLine. Always adds the end of line separator. And it also has capacities, clears, and ensure capacity. I don't know what get chunks does. I haven't actually tried that. Yeah, I've not used that, so we can look at that later if we want, but append's usually what you want. Maybe you might want remove or replace. They work like toString or like strings. But that's a string builder, and they can be really powerful. Like I said, on this example, the string's too small to really matter for. We're not doing that many appends, but when you're doing thousands, you can suddenly start seeing it slowing down a little bit, and this speeds it right back up. Say thousands. The example I'm thinking of may actually be millions, but we'll ignore that. But here we go. Here's just a stack, and as you see, it wasn't too complicated. Let's look at the runtime. All right, so to begin with, all we're really storing is just the list of items, so the space complexity is linear. So as you add more items, it takes up more space. Pretty straightforward. And because of the list implementation, there's always going to be a little overhead. It's not going to be a ton. So push is really easy. So time complexity, big O of 1, constant. No matter what we're doing, well, that is a lie, actually. So it's usually 1. Unless resizing, then big O of n, linear. So there's the truth. So as long as we don't have to resize, we're good. So just adding is big O of 1. You just add and we're done. If you have to resize though, you have to copy all the items to a new array that's twice the size, so it becomes linear at that point. So pop just removes the last item. It doesn't resize it, doesn't shrink it if it drops below a certain threshold. Just removes the last item or throws an exception if it doesn't. So time complexity is big O of 1, and it is really. Fact, copy, peak is as well. It doesn't do anything different. Count is I don't think the count property actually redoes it each time. I think it keeps track, I hope. Clear is as well. Is empty. It is unless count doesn't do what I think it does. But I would think Microsoft does count properly. Let's see. C# list of T. Properties count. Retrieving the value of this property is a big O of N operation. So you can see that from the Microsoft documentation. Go here, let's Firefox. I opened it on the real system instead of this one, sorry. Well, I was going to paste it in just to show what it was. Yeah, copy and paste isn't going to work. Do C# list of T. There we go, that's the one we want. Properties count. It's in remarks. So retrieving this value is this. So for them to be doing that, as we've seen before, they need to be storing the sizes they add, but that doesn't add a lot. It would add more to have to recount each time. So that's good. ToString is special. It is time complexity big O of N linear. The reason it is because you have to go through the list each time. You have to go through each list item and join it together to the string. There we go. That was a really quick complexity analysis, but because stacks are really easy. In fact, if we go to the big O cheat sheet here, I believe we'll see it in here as stack, yeah. Wait a minute. That's not what I. Oh, we're not searching. So searching, yeah. Searching is just searching a list, so you just have to go through it. And access. Okay, so I'm saying pop operation itself is a 1. This is saying to access a specific item. So say for my example, we want the first item off the list. You have to pop everything off the list. So yeah, we could agree with that. I think deletion then should be big O of N too, but at least insertion. I'm actually not sure I agree with it. I'd have to think more. I think insertion is not that. I think it's amortized to be. That means it's usually that case, but when it happens that you have to resize, then it's no longer that. I'm not sure I completely agree with this actually. If we're accessing a specific element, yeah, sure, maybe O of N in worst case. If you're accessing the first element, I think it's O of 1. So disagreement there. But either way, yeah, either way, that's the stack. So stacks really aren't that complex. You might have trouble thinking of a good use of a stack at first, but in reality, they're used quite a bit. They pop up a lot, especially in the lower levels of programming. you run into stacks quite a bit. If you're doing anything with compilers or programming languages, stacks show up a lot there as well. Next time we're gonna return back to our previous lesson, file navigation, and we're gonna implement the breadcrumbs here via stack and do a little more cleanup to the file navigation project. After that, we'll probably move on to queues. Queues is very similar to stack. In fact, you can see it is the next thing on the list here. I would say that, in my opinion, the queues are a little more complex than a stack, but not a lot more complex. Within the same ballpark. All right, so I think that does it for the day's lesson. So in the day's lesson, what we did, we looked at the data structure of a stack, which you can think of as just like if you have a stack of plates, you put one plate in, and then you put another on top and another on top, and as you take them off, you start with the topmost one and take it off and take it off. The idea is you push items onto a stack and you pop items off of the stack. We looked at implementing a stack via a list of T. So that's the backing data structure of the list. Then we just push items on the stack and we just add them in line. So that way we can just grab the last item off and treat the stack like that. Pop does exactly that. It just grabs the last item and removes it. Peek does the same thing but doesn't throw. It returns null and or whatever the default value is instead. Count here is empty. None of them are really all that impressive. To do that, what we did then did was we created a little program here where we used a new feature called a string builder, which is basically a more efficient string. Strings are immutable, so once they are created, they can't change. String builder fixes that, or fixes isn't the right word. That's an intended feature, but string builder lets you get around that. So it's more efficient. We weren't using any majorly long anything, so we weren't really going to see an advantage there, but this is a little more efficient using string builder appends rather than concatenating with a regular string. But we used a stack here, popped all the items on the stack, then we pushed all the items onto the stack, and then we popped them off and doing so we get the reverse order. So just a really quick example. What we did, we tokenized the string, we turned it into separate items based on faces, and then we pushed them onto the stack. Then we peeked to check, make sure there was an item, and then we popped the stack. So we removed the top item, and we just appended that to the reversed word or the reverse sentence, and we did that until we were done. And then we just reversed up to string, and you have your reverse string. So it was really simple, really easy, and something that I've personally used a couple of times since then. So I think it does show up, but maybe it's just my field. But you will see. I think if you get, especially in the low level, you will see stacks. You get in the networking, you might also see them, but I think that's where the upcoming lesson of queues might actually come in more. That's all I wanted to cover today. So that's a stack. Next time we were looking to using a stack, and it won't be the one we built. We'll use the built-in .NET one because there is one in the systems.generic.collections. But we'll use that stack to expand our file navigation from last time. So that'll do it for the day. So thanks for watching and have a wonderful day.